Welcome back, everybody. This is part 3 of 4 in my lecture series on solving quadratic equations. If you haven't seen the first 2 parts, I'd recommend you go and watch those now. Because in this video, we're going to talk about completing the square. This technique is used when neither factoring nor the square root property are going to help us solve the quadratic equation. Let's get started. Completing the square is based around this identity that I have up here at the top, that x squared plus bx plus b over 2 squared is equal to x plus b over 2 quantity squared. Well, we can verify that identity really quickly by just FOILing out the right-hand side. Remember, any number squared is that number times itself. My first terms give me x squared. My outside terms give me b over 2x. My inside terms give me b over 2x. And my last terms give me b over 2 squared. Combining like terms, I get the left-hand side. So sure, this identity holds. But how does it help us to solve quadratic equations? Well, in this first problem I have, it's a little bit more clear. Notice I almost have something that looks like this left-hand side, but I'm missing the b over 2 squared term. In this case, b is negative 12. So b over 2 squared would be negative 6 squared, or 36. So if I had, hypothetically speaking, if I had x squared minus 12x plus 36, then I would know what to do with the left-hand side, right? I know I would get x plus b over 2, or minus 6, squared. And that's a much simpler problem to solve. Well, let's just add. Let's just add the 36 in. Oops. Or take it all away. Because if I can just add the 36, as long as I add 36 to the right-hand side as well. And now, oops, I have a problem that I know how to solve using the square root property. Go ahead and pause the video here to see if you can do it on your own. The solutions to this problem are x equals 0 and 12. Notice from where you left off, I need to take the square root on both sides. On the left side, that's just going to leave me with x minus 6. On the right side, I actually have a perfect square. So when I take the square root, I get 6, but according to my square root property, plus or minus 6 are going to satisfy the problem. Now I add my 6 over, and I get 6 plus or minus 6. In the event it's plus, I get 12. Minus, I get 0. Let's try another one. This one is a little bit more complicated, because notice here, I don't quite have something that almost looks like the left-hand side. I've got a 5 here. Well, there's a really simple way to get rid of it, and that's to just divide it over to the other side. If I divide both sides by 5, then I will get x squared plus 3/5 x equals 9 over 10. And now I have something that almost looks like the left-hand side. Go ahead and pause the video here to see if you can finish completing the square. I got a bit of an ugly answer, that x should be negative 3 plus or minus 3 root 11 all over 10. But how did I get that answer? The first thing I did from the point where I left you off was I looked at what my magic number b over 2 squared should be for this problem, and it turned out to be 9 over 100. So I added it to both sides. Then the left hand, dang it, The first thing I did from when I left you off was I found what my magic number should be, that b over 2 squared, and it turned out to be 9 over 100, so I added it to both sides. That left me with something like the left-hand side and the completing the square identity. So I was able to write the perfect square, x plus 3/10 squared, on the left-hand side, and simplifying the right-hand side, I got 99 over 100. Taking the square root on both sides canceled the square on the left-hand side and left me with plus or minus 3 root 11 over 10 on the right-hand side. Last thing I had to do was subtract the 3 over 10 from both sides to get the final answer. In this video, we learned how to complete the square to solve quadratic equations, but we have an alternate way of solving quadratic equations that we still haven't talked about yet, and that's what we're going to talk about in the next video. See y'all then!